Bismillahirrahmanirrahim. Assalamualaikum and good evening to all my viewers. I am Muhammad bin Effendi, student 4th year from Civil Engineering Department, National Defence University of Malaysia. Will be presenting about my poster thesis, which focusing on site surveying information. So let us move forward to know about who is my supervisors and who is my co-supervisors. So as I mentioned before, I will be introduced to you who is my supervisor and co-supervisor for my thesis. So both my supervisor were lecturer in National Defence University of Malaysia. So my supervisor name is Nezar bin Ismail and my co-supervisor name is Wan Muhammad Shafwan bin Wan Muhammad Sabri. So as the slide shown to us is bridge condition monitoring using terrestrial laser scanner is my title of my thesis. So let us move forward to my background of my studies. Bridges are among the most vulnerable and yet critical components of the road network system, and they must be thoroughly inspected and maintained. Nowadays, terrestrial scanner or TLS is widely introduced in surveying course to assist surveyors complete their tasks effectively. The major purpose of bridge condition monitoring is to evaluate the structure's reliability and lifespan by measuring in-service effectiveness and identifying material degradation. So the study looked on developing new technologies and enhanced monitoring procedures utilized in the field of bridge condition monitoring to overcome the limits of visual inspections. Statistically, there were almost 8,205 bridges in service across Peninsular Malaysia in 2010 that is still in a condition monitoring conduction. So let us move forward to our problem statement and objective. What is my problem statement? So as mentioned before, bridge condition monitoring is currently in using of visual inspection method. So this traditional practical inspection and condition assessment method based on on-site physical inspectors include a time-consuming, expensive, and potentially dangerous. As mention of time-consuming, let us assume what is mentioned before about 8,205 bridges that is still in condition monitoring conduction. Can you imagine if only one bridge that only need 3 hours to complete the inspection of bridges, how many times or how many years that it will take to complete almost 8,205 bridges? So the second problem statement is the accuracy of data using TLS is still in research as it's still in initiation phase in most countries. So the main problem statement is first is time consuming, hazardous, and the accuracy of the data using the proposed method, which is using the TLS. So we move forward to the objectives. So first objective is to produce 3D model from TLS data. The second is to compare the accuracy of actual measurement by using the measuring tape and TLS data. And the third is to evaluate the feasibility of using terrestrial laser scanners for bridge condition assessment data collection. So let us move forward to some of equipment that I need for me to complete my thesis. So it divides to two devices, which is software and hardware. So for the software equipment, we use the Cyclone Field 360 and a Cyclone Register 360, which is related to the scanner technologies. And the third software is Autodesk Revit to produce the 3D model. The second part is hardware. So the first is measuring tape. Second is TLS Leica RTC 360. And the third is using the high-end laptop. So let us move forward to methodology of my research, divided to 4 phases, which is preliminary study, preparation of study, third is data acquisition, last is data processing. So for the preliminary study, I'm doing on a literature review on current bridge condition monitoring and TLS method, the comparison between the visual inspection and the proposed method. So it will be explained more detail in result and analysis. Second is preparation of study. So as I mentioned before, there is some software that it need to be installed. Then site reconnaissance for data collection. So the bridge that have been selected for me to do my research is the bridge near to the LRT of Tasik Selatan, and that is equipment setup. So in result analysis, I will be show you all my viewer 15 points that I've been set up my equipment to complete my 3D model information. Next is data acquisition. So data collected using the TLS Leica RTC 360 based on the setup point that I've been pointed out. Then the second is manual measurement for bridge part specified using the measuring tape. So some bridge part that have been selected for me, easy for me to measure, so it is used to be compared to the measurement in software, which is Cyclone Register 360. So the last is data processing. So data collected using TLS and Cyclone Field 360. So Cyclone Field 360 is used for the data collection for the TLS data. So all the data from the Cyclone Field 360 will be converted to Cyclone Register 360 for point cloud linking, and then 3D model of bridge will be constructed using the Autodesk Revit software. So let us move forward to result and analysis. So this is what I have been mentioned before, which is the point cloud data processing using Cyclone Register 360. So if we really focus on the point cloud data processing, there will be 15 setup points of my TLS from the object to easily construct the 3D model by developing the Cyclone Register 360 converted to the Autodesk. So the second is point cloud data from the Register 360 convert to Autodesk Revit, and then 3D model of bridge will be constructed by using this software. So the third picture below of the explanation that I've been explained before. So there is example of bridge damage from Cyclone Register 360 that have been captured using the software and the TLS data. So I've been mentioned before about some bridges part that I measured using the measuring tools, measuring tapes. It is used to be compared to the TLS 3D model from the Revit software and also the Cyclone Register 360. So three of these methods will be compared to find the tolerance value of the proposed method, either it applicable or not to use to field works. So those picture A, B, C, D, E, and F. So bridge part, and as you can see, the difference, the TLS 3D model differ to the manual measurement. The RMSE, or root mean square error, is 0.0076, while TLS Cyclone Register 360 compared to the manual measurement using the measuring tape is 0.0059 for the RMSE. So this is the analysis of protocol observation. As I mentioned before in my problem statement, about the labor intensity, about the hazardous, about the time consuming, about the cost estimation. So all of these observed by only doing the visual inspection, comparison between the proposed method and the visual inspection using the manual measurement. So as you can see, the labor intensity for the manual measurement using 2 manpowers, same as TLS, also using 2 manpowers. For the hazardous is contact technology for the manual measurement, and for the TLS, semi-contact technology. As for the time consuming, it divided to 4 phases, which is time for equipment setup, time to obtain data, time of data processing, and the total usage of time. So time for equipment setup, for the manual measurement, yeah, when we use the measuring tape, so it is not in list because it doesn't in need of time. But for the TLS, for the equipment setup, it in need of 30 minutes. Second row is time to obtain data. For the manual measurement, for the all the bridges part, it in need of 3 hours to complete the measurement of one bridge. But using the TLS, it is only in need of 1 hour and 30 minutes to complete and to get the 3D model of the bridge. So time of data processing, as the manual measurement doesn't need the data processing of software, so it doesn't need any time. But TLS in need of 24 hours. It depends on how many points that we set up on the TLS, so it will affect the number of the point cloud. So the higher number of point cloud, the longer it takes for it to process, so the longer time it takes for it to complete the model. So for the total usage of time, yeah, manual measurement is just only need 3 hours, but the TLS in need of 26 hours, more than a day. So that is some disadvantages of this TLS. Next is the significance of research. So first is the study can develop the TLS application for building forensic investigation. And the second one is the finding of the study provide evidence for the newly proposed method as build data collection compared to the current visual inspection method. So the significance of research, it can depends on our objective. First is to produce the 3D model as build data collection. So all the objective were pointed to tally with the significance of research. So last for the presentation of my poster for today is conclusion. So the conclusion, the audience was shown how to model the 3D infrastructure using the raw information from TLS RTC 360 point cloud. As the RMSE for proposed to compare to actual measurement by using the measuring tape is still in range of tolerance value, like we see in the result, it's obviously show how applicable this technology of TLS in surveying information. So 3D model can be used as repository of all bridges in Malaysia. This can reduce the cost and time to conduct bridge condition assessment for all bridges. This research can define as a proof or evidence to enhance the implementation of this scanner technology in the construction industry, especially in our country, Malaysia. Thank you for all the viewers.